Good afternoon, everyone. Today is another day. We want to continue our class. Remember or recall that in our last class, we, we got our moment coefficients for the panel 4. Remember, we're working on panel 4. So this is the moment coefficient. All right. So we want to begin the same process again. The step you take to get your AS required. So we've gotten this. The positive coefficient is 0.048, negative is 0.064. So we move straight to calculating for our moment. Now, recall that UDL is equals to 14.52 kilonewton per meter square. All right. Our D still remains close to 124 millimeters. Okay. We have everything we want to work with now to calculating the moments. Now, remember, when we are dealing with the positive moment coefficient, we are actually trying to design for the mid span of our slab, for our panel. Okay, now we call this one mid span moments. Right? Now, recall the same process. Positive coefficient 0.048 multiplied by UDL 40.52 multiplied by our span. The span is 3.825 square. All right. You want to know how we got this span? Go to the previous class. The span is there. The panel slab is 3.825 by 7.025. So where is the shorter span? All right. So when you compute that, we are going to have when we go to the calculator, I'm going to have 0.048 multiplied by 40.52 multiplied by 3.825 square. We have 10.2 approximately. Alright, this is now equals to 10.20 kilonewton meter. This is also equal to 10.20 times 10 raised to the power 6 Newton millimeters. Alright, we have gotten our moment for the mid span. Alright, the next step is to calculate for our K. Alright, recall that K is equals to moment 10.20 times 10 raised to the power 6 over characteristic strength of concrete, which is 20, multiplied by 1000 multiplied by 124 square. This must be less than or equal to 0.156 as usual. Alright, when you compute this, we're going to have divided by 20 times. We're going to have 0.033. This is equal to 0.033. Alright, this is less than 0.156. Alright, we use the lesser value. Okay, the next step is to calculate for our lever arm. Recall that, for the sake of this lecture, we're still going to continue with this design. Recall that in one of our panels, we had a value was 0.033. All right. So and that our LA we use 0.95. Okay. So, but for the purpose of this lecture, we can continue. But if you don't want to waste your time, since you have this one before your previous design, you can still adopt that particular reinforcement. Okay, so let's continue. Next step is to get our LA, which is equals to 0.5 plus square root of 0.25 minus K. What is our K? 0.33, 0.033 over 0.9. Okay. Now let's compute. Let's compute this. 0.5 plus square of 0.25 minus 0.033 divided 0.9. Now give me 0.96. When you compute this, you give me 0.96, which is greater than 0.95. Recall that I told you that we use 0.95 before, so we are going to make use of 0.95 because it's the lesser value. So our Z now becomes 0.95 multiplied by 124, which will now give me 0.95 times 124. Also 117.8 millimeters. Okay, that's what we are making use of right now. So we'll continue. We'll now solve for AS. AS required. This is the AS required for the building to be safe. All right, for the structure to be safe. So now have that AS equals to 10.20 times 10 raised to the power 6 over 0.95, which is a constant, multiplied by 410, which is characteristic strength of steel, multiplied by our Z, 117.8. All right. So if you compute this, you have 10.2 exponential 6 divided by 0.95 multiplied by 410 multiplied by 117.8. This one will give me 222.30 millimeter square. I haven't gotten this value for our AS required. You now go to the BS code to provide, look for a number or the value that is closest to this. All right. Like I always say, because reductions is still produced here, when I go to the BS code, the nearest value was supposed to be 377 millimeters square, which would have been 12 mm at 300 center to center. I will jump that. I'll go to 250. All right. So I will now come here, say provide Y12 millimeter diameter bar at 250 millimeter center to center. All right. Now, where are we now going to place this one now? Because I told you that when you are designing for mid-span moment, the span moment, the tension is at the bottom. So you put your reinforcement at the bottom. Now call it bottom. All right. So after getting your value, you can come to this point. This is the output. You now say Y12 at 250 center to center, bottom. I say AS provided is equals to 452 millimeters square. All right. You go to the BS code. The area provided will now be 452 millimeters square. Okay. We have solved for the mid-span moment. We can now go to the continuous edge. All right. You can now go to the continuous edge. Okay?